In this video, I'm going to show how to use laws of exponents to simplify algebraic expressions. Before we begin, let's first review the laws of exponents we should know. The first one is when we multiply powers and the base is the same. In this case, we need to add the exponents. If you ever forget, think of an example. If I have x cubed times x squared, that's the same thing as if I had 3x's multiplied by each other and another 2. Now we can see that we have 5 of them, which is the same thing if we were to add the exponents 3 plus 2, giving us x to the exponent 5. With a quotient, we again look at the base. If the base is the same, we subtract the exponents. When a power is raised to a power, we have to multiply exponents. In the case when you have a product inside a bracket, we use the distributive law to apply the exponent to each part of the product. Similarly for the quotient, we distribute the exponent to each part of the quotient. When we have a negative exponent, it would be the same thing if we had a reciprocal with a positive exponent. The same idea works if you have a negative exponent in the denominator. We can take the reciprocal, which gives us expression with a positive exponent. And anything raised to the power 0 is 1. So let's take a look at our example. In this case, we want to simplify numerator and denominator. And in a numerator, notice we have brackets. Before we use the distributive property and the law for power raised to a power, let's rewrite the cubed root as exponent. It would be the same if we had exponent 1 over 3. So using the law of power raised to a power, we are going to multiply the exponents. 2, the constant, has exponent 1, even though we don't have it written. So we're going to multiply the exponents. We'll have 2 to the power 1 times 3, which is 3. Then x, we go exponent 1/3 times 3. Y to exponent negative 2/3 times 3, and we'll simplify that after. In the denominator, we look at possibility multiplying if anything has the same base. First, let's multiply the constants. 5 times 2 is 10. Then we have x to the power 2 and x to the power 3. So we're going to be using the first law of exponents. Because the base is the same, we're adding when we have a product and the same base in a product. And there's nothing we can do with y to the negative 2 for now, but we'll deal with it later. Let's simplify this a little bit more. So we have 2 cubed is 8, x to exponent 1, which we don't have to write down. Then we have y to exponent negative 2, all over 10, x to exponent 5, and y to the exponent negative 2. Now there's 2 ways you can simplify this. We can use a law of cancellation, or I'll use the fact that it's a quotient and the base is the same. We are going to subtract the exponents. Similarly for x over x to exponent 5. Let's also simplify the constants. We can see that 2 goes into each one of these. So 8 will become 4, 2 goes into 10, 5 times. So that reduces to 4 over 5. So we'll still have 4 over 5. But now in a numerator, we'll have x to exponent 1 minus 5. Using the second law on the right-hand side, when base is the same, and we have a division of powers, we subtract the exponents. And y to the negative 2 minus negative 2, or we could have canceled those. We'll leave it at that. So we have x to the negative 4, and of course this becomes y to the negative 2 plus 2 when it's double negative, becomes y to the power 0, which simplifies to 4 over 5 x to the negative 4 times 1, which we don't need to show the multiplication by 1. Sometimes you will want to make the exponent positive. It's not always the case that it's necessary. If you're doing calculus and you're doing derivatives, You may find it easier to do it with negative exponent, but when we're evaluating, it may be easier to see what's going on when we make the exponent positive. So in order for us to do that, because the exponent is negative and it's in the numerator, so we bring it down and make the exponent positive. And that is our final answer.